Okay, this is AP, AB, and BC Calculus. We're doing Unit 2, Section 5, which is applying the power rule. All right, so in general, you won't be asked to differentiate using that limit definition the long way that we learned very often. You're far more likely to see that as a multiple choice question that requires you to spot the pattern and know based on your other knowledge that you are differentiating and then skip to the end using that knowledge. So instead, we're going to learn about 24 differentiation rules that we're going to apply to find derivatives of functions. In this section, we're going to learn the first one of these rules called the power rule. So a quick bit of notation, when you see a d dx, right, so it's a d over a dx, but we frequently just say d dx. So when you see this, right, this thing is essentially a command telling you to differentiate. So for example, d dx of f of x would be f prime of x. So I'm differentiating with respect to x. So let's go ahead and get right into the power rule. So for the power rule, if you're given some x to a power, right, so x has to be your variable, right, n has to be a number, right? So if you have an x to a number and you want to differentiate, you do that by dropping the n down in front as a coefficient and then lowering the exponent by 1. So for example, if I differentiate x to the 5th, I'm going to drop the 5 down in front as a coefficient and I'm going to lower that exponent by 1, 5 minus 1. So my answer would be 5x to the 4th. Nobody thinks it's cheating if you jump from here to here, right? As you get better at this, you're going to be differentiating pretty quickly, hopefully, and you're not going to spend a ton of time writing things like the 5 minus 1. Now, if I give you something like the derivative of 1 over x cubed, I need to rewrite that x cubed as an x to an n, right? So I'm going to rewrite that as d dx of x to the negative third, because remember that if I want to flip an exponential expression to the other floor, I make the exponent negative. So now when I drop this power down in front, the negative 3 becomes the coefficient, right? This becomes the coefficient. And then I lower the power by 1, which means I'm going to get negative 3x to the negative 4th, because 1 lower than negative 3 is negative 4. The other way you might see this written is a negative 3 on top of an x to the 4th, right? Either of those answers would be fine, but that's what that's going to look like. If I give you something like the derivative of the square root of x, I need to recognize that the square root of x is actually also an x to a power. It's an x to the 1/2. So when I rewrite it as next to 1/2, the 1/2 comes down and becomes the coefficient, right? And then the exponent will now be x to the 1 minus 1/2, which means I get a 1/2 x to the negative 1/2, which is a fine answer, or you'll see it as a 1 over 2 root x. So that's the power rule. We're going to practice using the power rule in this video. All right, so given that f of x is x to the 8th, let's find f prime of x. So my f prime of x is going to be, I'm going to drop the 8 down in front, and I'm going to lower the exponent by 1. So I'm going to get 8x to the 7th. Now, if you were thinking, Hogan, why would you write this? You don't have to write the middle stuff, right? If you in your brain are like, cool, I can do 8 minus 1, I'm all good, Hogan. That's awesome, congratulations. You just need to skip to the end, okay? And if you need this step, great. If you don't need this step, also great. All right, let's go ahead and do a P1. You try it before me, pause me if you don't want me to do it. So my f prime of x is going to be a 6x to the 5th, right? And the way I got the 5th was by doing 6 minus 1, right? Keep moving forward. All right, so now I have y equals the cube root of x. Now I'm going to need to rewrite that and recognize that that's the same as an x to the 1/3. So what that means is that my y prime, or dy dx, if I want to use, so the notation they gave me was find dy dx, so I will use the notation that they gave me. Dy dx is going to be, I drop the power down in front, and I lower the power by 1. Now in this situation, I would suggest that you write it out because a lot of us aren't great at lowering this power by 1. That's a 1/3 minus a 3/3. So I'm going to get that my answer is a 1/3 x to the negative 2/3. That answer is totally fine. Or, if you want, you could flip it to the bottom and say that this is a 1 over a 3x to the 2/3. That's also fine. If I were you, I would stick with the easiest answer. I would only simplify if you have to math more with it, right? So like if I have to do more things with it, right? If I have to solve something, sure, I'm going to simplify if I have to factor something or solve something or whatever. But if I just need the answer, I'm just going to stop here, right? So I would stop here if they only ask you for the answer, which is what the question asked here in example 2. doing extra math just exposes you to the chance that you're going to make a silly error. I make a million silly errors a day, math and otherwise, right? So the more stuff we do, the more errors we risk making, and we want to minimize those. So just do exactly what you're asked. If you have to use a fraction or an expression more, then you might want to simplify. But if you don't have to use it, you should just stop when you get a right answer and call it a day. All right, go ahead and try a P2. You can pause me if you want. That's a fifth root of x. So before I differentiate, I need to rewrite this as an x to the 1/5, right? So that's actually not calculus, right? That's pre-calc. So then my dy dx is going to be a 1/5 x to the 1/5 minus 1, right? Well, that's a 1/5 minus 5/5. So I'm going to get a negative 4/5 as my exponent. So I can write it like this. That's great, okay? I can also write it as this, 4x to the, or sorry, that's not a 4. Come on, brain. See what I mean when I say I make a million mistakes a day? And you're going to do that at some point, unlike an AP. You're going to have the right answer, and then you're just going to miscopy your own work and get super mad, because we've all been there. All right, so this is also fine, right? This is probably the best lazy answer. And what I forgot to write on the last one, and I'll go back and put it there now, is you could also rewrite it as a root. It's just a weird choice, right? Like, all of these are fine, but it would make way more sense, right? So 1 over, you could have written this as 1 over the cube root of an x squared. Again, they're also fine, but like, this is by far the easiest option. Don't make your life harder than it has to be. Math is hard enough without making it worse. So I would stick with this answer right here, unless you have to simplify in some way. Like, unless you have to simplify or are asked to use it, I would stick with the easiest answer. All right. E3, so we're given y, let's find y prime. So the first thing we have to do is some pre-calculus. We need to realize that this is actually an x to the negative 8th, which means that my y prime is going to be a negative 8 x to the, and then this is negative 8 minus 1, which is going to be a negative 9. So it's going to look like this. If you want to simplify it all, you can put the x to the 9th back on the bottom. That's also fine. And here I would argue that those are about the same level of difficulty, but I think with the fractional exponents, it's really a different level of difficulty to simplify, and it's not necessarily worth it. So whichever of these makes you feel more comfortable is fine. Go ahead and try a P3, right? So again, the first thing you're going to have to do is rewrite this, right? And then your y prime is going to be negative 10 x to the, and if you can jump to negative 11, that's great. And if you can't jump to negative 11, then that's also fine. So this answer is great. If you want to put it as a negative 10 on top of an x to the 11th, that's also fine, right? Cool. Let's go ahead and do an E4. So given f of x, find the equations of the tangent line and normal line at this value. So we've talked about how to find equations of a line, right? Anytime I need an equation of a line, I need two things. I need a point, which I have half of right now, right? The point is 2 comma blank. I can find the other half in a sec. And I need a slope. Right? And that's true not just in calc, that's true in all of the math that you've learned since algebra, right? So I need a slope. Remember that for part A, my tangent slope is going to be the derivative evaluated at 2, right? And for part B, my normal slope is going to be the opposite reciprocal, right? It's going to be the opposite reciprocal of whatever I got for the tangent slope. So the first thing I'm going to suggest you do is find this point, because that's not actually any calculus, right? So this point is going to be f of 2. I just have to plug in and get 2 to the 5th, which is 32, right? So this is going to be a 32 because it would be 2 to the 5th, right? That kind of looks like a 25. It meant to look like a 2 to the 5th. Okay, so I plug in and get a 32. The next thing I have to worry about is finding my tangent slope. Well, in order to find my tangent slope, I first need to differentiate. So my f prime of x, using the power rule, is going to be a 5x to the 4th, which means that f prime of 2 is going to be a 5 times a 16, or an 80. So that is my tangent slope, right? What that means is that my answer to A is y minus the y value equals m, my tangent slope, x minus the x value. And you should absolutely leave your answer like that. If you really stubbornly insist on solving for y, just add the 32 over. Please don't bother to distribute. It's just going to be a mistake. It's much better to say, hey, I'm going to leave this. Don't bother. If you distribute, you'll be shocked by the number of times you distribute incorrectly. For B, it's exactly the same setup, except instead of using an 80 for my slope, right? So my normal slope is the opposite reciprocal, so I'm going to use a negative 1 over 80. That's it. And if you want to write your normal slope or your normal line solved for y, please do the same totally lazy thing where you just add the 32 over, okay? don't distribute. And you can see it more clearly here where the slope is a -1/80, that if you distribute, you're going to have ugly fractions and no one's going to have any fun. Both of these answers would have been fine that I didn't box. But if you feel compelled to solve for y for whatever reason, the easiest way to do it is to just add the y value over. You are under no obligation to distribute and simplify. All right, let's go ahead and try a P4, same thing, right? You're going to find the tangent and normal line equations. So you will, anytime you're asked for the equations of lines, you need two things. You need a point, which you have half of, right? You have 9 comma blank, right? And you need a slope, right? And for A, your tangent slope is going to be f prime evaluated at 9. And for B, your normal slope is going to be the opposite reciprocal of that. So, so let's go ahead and start by finding the point, right? So I'm plugging in f of 9, which would be the square root of 9, so I get 3 as my point, right? For my slope, I know that f of x is an x to the 1/2, so my f prime of x would be a 1/2 x to the -1/2. Now this is one of those cases where it's probably worth rewriting because I don't think you really want to do a 9 to the -1/2 and think through that. So my tangent slope is going to be f prime of 9, which is a 1/2 root 9, or a 1/2 times 3, which is a 1/6. That means that my normal slope is a -6, right? Flip slope, instead of 1/6, it's 6/1, and change the sign. So my answer to part A is y minus the y value equals m x minus the x value, or if you solve for y, it'll be y equals 1/6 the quantity x minus 9 plus a 3, right? And my answer to B will be y minus 3 equals -6 times this quantity x minus 9. If I solve for y, it would be a -6 times the quantity x minus 9 plus a 3. And those are my two answers. Cool. And that is your video for Unit 2, Section 5.